Hi, welcome back. In this video we're going to create a color. For that I'm going to go ahead and click on the front plane and I'm going to start off by drawing a circle. Dimension this circle 41 and draw a center line vertically downwards. Go to the line and draw something as approximate as this one. Vertically down, horizontally right, and a little bit inclined up until you reach the circle again. Go to mirror entities, choose this, this, and this, and mirror them using the center line. Okay, dimension this one 3. The distance from here to here should be 5. Okay, in this case I'm just gonna have to manually pull them back. Yeah, the distance between them should be 0.5 millimeters and the height from here to here 10. That's what we want. We need another circle in the middle and the wall thickness should be 3 millimeters. That's it. Now we need to extend these lines way up to the inner circle. Again, it's because we want to cut here open. I just cut this open and cut this open, and because this is dimension, I'm not gonna cut it open. I'm just gonna click on it, or yeah, let's just cut it open. See what happens. Nothing. That's okay. Go to the Features tab and extrude the part for 15 millimeters, but do it mid-plane. Always work with mid-plane. That's my recommendation. That's okay now. Okay, click on the right plane, make it normal too, and draw a hexagon somewhere in the middle, approximately. Okay, good. Dimension this 6 millimeters, and the distance between this hexagon and your origin should be 23. Now right click on this hexagon, select midpoint, control key down, and click on your origin. Let go of the control key down and click on vertical. It is still underdefined because it tells me that we didn't do it right. Midpoint is vertical. Okay, let's just make this horizontal. Okay, that's good. We need a circle in the middle. Set it at 3. That's good. Now go to Features and choose Extruded Cut, because we're gonna make a place for the bolt and the screw. Now go to Offset, make it 2, reverse, something like this. Yeah, that's what we want. Open the feature, click on the sketch, click on the Extruded Cut again, open the selected contours. This time only select the inner circle, flip the side. That's what you should be getting. Okay, click on the right plane one more time, make it normal too. We're gonna have to cut the edges like that. Doesn't matter. Very approximate. And this should be 20 degrees, as well as this one on the left. We're gonna cut it through the part completely to give us our shape. That's more like it. Fillet this one at 1, radius 1. Also this, and this. Very nice. Again, right plane, normal 2, create a circle and another circle inside it. The outer one should be set at 10 millimeters and the inner one should be 8. Now go to features, extruded bus. This time go to from, make it offset 22 millimeters. Alright, reverse the direction and change the line to up to surface. Click on the surface and that's what we want. Before we carry on, open this sketch, extruded cut, and only select the inner circle. Make it go through all in both directions. Very good. As the last step, we're going to click on the right plane, go to mirror, click on this and this. It's more like it. This is not right, so I'm going to have to find this feature, edit it, and make it go in both directions. So everything good. Change the material to whatever you want. It should be a polymer, but I'm going to change the color. Yeah, that's much better. Let's just make it darker and save it under color. Hi everyone, welcome back. In this video we're going to create the hanger core. So for that, let me start off by clicking on the front plane and start sketching. I'm going to choose the line and start drawing something as approximate as this. Go up, don't go away to the end, just stop somewhere here and your line. And then do another one here. Now we're going to have a center line in the middle. Zoom in. We need a circle on the center line, doesn't matter where, and do it an approximate circle. Dimension this circle 6.1 and go back to mirror entities. Choose these lines that you just drew and mirror using the center line, exactly like that. Now these 2 points should be connected to your circle, so we're going to do that, and also these two, done and done. Good. Dimension this one 6 millimeters. The height should be 15 millimeters. This should be here, and this should be somewhere here. Yeah, that's very good. This is 2, this is 1.5, and this height should be 1. That's more like it. Now we're gonna go to tangent arc and use 3-point arc, using first these 2 points, do an approximate half a circle, and again the midpoints over here do another, right? Okay, now we're gonna make these 2 arcs concentric. So make them concentric, and also make this one tangential to this line. I'm just holding the control key down and activating 2 objects, and then I'll get all the relations I can apply to them over here. The dimension between the center of this circle and this circle should be 4. Distance between these 2, oh, they are interacting. So let me just get it out, yeah. And the distance between these 2 should be 0.1, and yep. Our sketch is now fully defined. Go to the Features tab and using Extruded Bus, extrude these 2 areas and set them at mid-plane for 15 millimeters. There you go. Now, since we're going to use our sketch once more, I'm going to open this feature, click on this sketch once, and go to the extruded bus again. Here, I'll get a chance to use the same sketch and apply a different extrude to it. Now I'm going to choose this arc here, make it mid-plane and extrude it for 9 millimeters. That's the base of our part. Now choose either size, or this, and start drawing a new sketch on it. From this corner to this corner, I'm going to draw a rectangle, and I'm going to draw a circle using a perimeter circle. I'm going to choose these 3 lines. What's going on here? Yo. Now I have my drawing fully defined. I'm gonna go to extruded cut and choose this area and extrude cut it for 1.5 millimeters. Again, I'm gonna open this feature, use the sketch, go to extruded cut, and use this area this time and make it go through all. Alright, now we're gonna use the right plane and mirror what we did over here. Not the body, I'm sorry, this is the wrong one. Go to the feature mirror and mirror it to the other side. Click on the surface, sketch, and draw the following. First of all, we need a rectangle. Second, we need a circle in the middle, but for now we'll just leave it there, doesn't matter. We're gonna have our rectangle 7.5 by 7.5. We're gonna have it midpoint, vertical to the origin. The distance to the bottom part should be 2 millimeters. It's now fully defined. Use the center line to connect these 2 corners to each other. That's good. Now we're gonna right click on the center line, use the midpoint, hold the control key down, and select our circle and let go of the control key. Now we can make them coincident. The diameter of the circle should be 4.1. Now they are fully defined, as you can see. Features, extruded cut, and make it go in 1 millimeters. Open the feature again, use the sketch, again extruded cut, this time selected counters, use these 2 half circles, make them go through all. There you go. Now we want the same rectangle here, so we're going to use the right plane, go to mirror, and do it over there. Very good. We're going to go to fillet, set it at 2 millimeters, and round these 2 plus these 2 edges over here. Before we carry on, we need 2 parts to fill these cavities, but they should not be connected to this main body, so we're going to use the same sketch again to extrude for 1 millimeter, reverse, but it should be a different part, so we're going to uncheck merge resolved. We're going to choose the right plane, go to mirror. This time we're going to go to body because it's a new body, it's not a feature, and mirror it. If you can see here, we have 3 solid bodies. One is our main part, and second and third parts are supposedly made of metal, while the first part should be a polymer, let's say ABS. I'm going to make it non-see-through by clicking over here and deactivating the see-through option. Good. Now you can see we have our polymer part and 2 metallic parts installed in it. Alright, so you can save it now under hanger core, and that that will be it. Hi, welcome back everyone. In this video we're going to create the hanger shell. Click on the front plane. Oh, I click on the top plane, doesn't matter. Click on the line and draw something as approximate as this. That's absolutely fine. Dimension this one 18 and the height 19. So these 3 points should be in the same line, and the midpoint here should be vertical to the original just to have it fully defined. Using the sketch fillet with a radius of 1, round this corner, and with a radius of 5, round the other. Very good. Now go to features, extrude, and using thin feature at 1 millimeter, and midplane, extrude it for 8 millimeters. Click on the surface with a bigger, with a smaller round. Draw a circle and a rectangle. Dimension this one 5.5, the height here 3, and the width 2. That's good. Well, what we need more, we have to have this midpoint, the center of the circle, and the origin in one line aligned with each other. Connect this point on the circle and dimension the distance between these two 5 to have it fully defined. Right? So go to extruded, cut, and make it go through all. Sorry, have to define the counters. Select all of them, all 3 of them, and that's it. Now again on the same side, click on the surface, draw a rectangle, set it as 3, and drop this on the line, and also this one on the circle. That's very good. Do this one 3. I forgot, this one should be 1 actually. Yeah. And go to convert entities and click on the circle. Okay. Go to features, select extruded bus, and use this area and extrude it for 3 millimeters. Now go to fillet, set it at 2 millimeters. Click on these 4 edges, one here, here, and here. Change the material to 1060 alloy and save it under hanger shell. Hi, welcome back. In this video we're going to create the hex nut. Let's start again by clicking on the front plane and doing a sketch. I'm going to start off by creating a polygon 6-sided exactly in the center of the page and dimension it 6 millimeters. This is still underdefined because it doesn't know whether each side should be horizontal or vertical or whatever. Now it's fully defined. Go ahead and extrude it for 5 millimeters and click on the surface, draw half a circle on top of it, and just click on creating sketch. Do a half circle, connect these 2 points together, and because it is still not fixed, right click on the line, select midpoint, hold the control key down and select your origin and click on coincident. Now make this one vertical. Now it's a half circle. Dimension it 2.3 on its radius and go to revolve set it at 180 degrees and choose this line as your axis. I think it did it from the inside, so we're gonna have to turn the side, yeah, like that. Now, come here, click on the surface, sketch, and draw a circle. Set it at 3 millimeters and extrude it in extruded cut for 4 millimeters. Go to Insert, Annotations, and Cosmetic Thread. Choose your edge, M4, and leave it there. You can also do one extra step and draw a circle again on the top inside your polygon, like this. Go to Features, Extruded Cut, and activate Flip Side to Cut. Activate the draft and do it more until it looks okay, something like this. Yeah, 26 degrees, that's okay. And that's your nut. If it's too much and you don't like it, you can increase the number until it looks acceptable for you, because it's just optical. Like that. And change the material to whatever you want. Plain carbon steel, and save the file under hex nut. Hi, welcome back. In this video we're going to create a knurled screw cap. Go ahead and choose the front plane. Now activate the sketch and use line to create a pattern as approximate as this one. Right, so let's do some dimensioning. 8 millimeters, also 8. This will be 4. This 6 millimeters. Let's manually drag the sketch up to, yeah, that looks better. That should be 2 millimeters. And from here to here should be 4 millimeters. So the sketch is fully defined. Sketch chamfer here. When you click on the arrow, you have to sketch chamfer, set it at 1, and click on this point. Go to the Features tab in the Revolve and use this line as axis to revolve your part. So that would be your base to work on. First thing first, click on the surface and go to Sketch, draw a center rectangle. Doesn't have to be center rectangle, it has to be a rectangle in the center, so I will leave that up to you. The width should be 2 millimeters and the length should be larger than the diameter of your screw. So it's not really important as long as it's larger than that. Go to Extruded Cut and set it at 2 millimeters and click OK. So that's the rough base. Click on the surface, choose Sketch, draw a circle co-radial with the largest diameter of your screw. You see this orange color, now you know it's co-radial. Click on Helix or Spiral. You'll find it in Insert, Curve, and Helix/Spiral. These are the parameters you will use. Defined by is pitch and revolution. Constant pitch should be 60 millimeters. Revolution should be quarter of a revolution. Revolution is 1/4 of a revolution, start angle 0, and let's start by clockwise. Click OK. That would be your path. Again, click on the very same surface you just did, activate sketch, go to polygon, set it at 3 sides to create a triangle, and draw a triangle on the surface. Try to set the center of your triangle on the starting point of your spiral. 0.6 millimeters should be the side of your triangle. Now drag the center on the spiral and reveal the sketch. You don't need extra dimensions to fully define it because it's just there for the matter of optics. Go to Subcut in the Features tab, click on the triangle, and then click on the path, and right click as OK. Again, we're going to repeat the same procedure on the same surface, sketch. Again, a circle, co-radial, insert, helix, a curved helix. This time, same parameters, only counterclockwise. Click OK. Same surface, sketch, polygon. Again, another triangle where the first one was 0.6 millimeters. Drag this point to that point. That will be okay. Features, Subcut, profile, and the path. Now go to the Features tab, linear pattern, there is an arrow underneath it, and choose circular pattern there. So, choose these two for your feature and set the pattern amount at 40 and choose this circular edge in order to set the axis that you want these two features to be 40 times repeated, and choose the axis that you want these two features to be rotated around for 40 times. It will take a couple of seconds, and that will be it. This is the knurled screw cap. You really don't have to do this part now, but when I did the part, I did it exactly the way the original parts looked, so I'm gonna do it also here. This should be 0.3. I'm gonna go to the Features tab and extrude, cut it for another 0.3 into the body. And if you want, you don't really have to, can go to Annotations and add Cosmetic Thread to create an official part. Change the material, screw, and save the part under knurled screw. Hi and welcome back. In this video we're going to create the leg, of which we have 2 in our assembly. Choose the front plane and create a sketch on it. By sketch I mean a normal line which goes way up vertically, and after that it goes even further up but with a little bit of angle. This distance over here should be 7.5 millimeters, while the height, alright, while the height should be 265 millimeters. There you go. Good. These two parts should be equal, so I'm gonna hold the control key down, select both of them and click on equal. That's it. Sketch fillet, set it at 1000 millimeters and hold this point. Yes! Thank you. And that would be it. Good. Now we have our path. That's good. Choose the top plane, zoom in, create a rectangle exactly in the middle, set each side at 8 millimeters. Oh, I'm good. And round the corners by 0.6. All 4 of them. Yes. Boom. Down. Yeah. Alright. So we can rebuild it and go to the Features tab, select swept bus, choose the profile and choose the path and click OK. Now, almost finished. We need to choose the right plane and draw the following on it. First of all, a circle here, and it should be 3 millimeters in diameter and 5 millimeters apart from our edge. Don't forget that the circle should be in a vertical relation with our origin in the Y direction. It's not finished, we need another one here. You see, I can see this edge because I'm not looking at it exactly at a 90 degrees angle, but it doesn't matter. All I need is a 3 millimeter circle with 5 millimeters of distance from this edge, not this one, 5. Alright, good. And as I said, I want to right click here, select midpoint, control key, circle, vertical, that's it. Through the cuts, through all, both directions. Yeah, thank you. Almost over. Again, right plane, normal 2. We need one circle here. Yes, also 3 millimeters. And the height should be 132. Good. And just select the center and the origin, make them vertical. Alright, you see, this is in the middle. It's not going to cut it through the whole part. In this direction, where the curve is smaller. Select the material at 1060 alloy and save it under leg.
Hi, welcome back. In this video we're going to cover the spring. Go ahead and choose the front plane. Draw a circle and set the diameter 8 millimeters. Now go ahead to insert curves and click on helix or spiral. Good. Now make sure it is being defined by pitch and revolution. Constant pitch, your pitch should be 2.1 and 36.5 rounds, and clockwise. Your start angle should also be 0. Good. Now, choose the top plane and go to one end of the spiral. Click on the sketch and draw a circle where your spiral ends or starts, for that matter. Set its diameter 1 millimeter and click rebuild. Now go to features and click on swept bus. Choose the circle for your profile and choose the spiral for your path and right click as OK. That would be your spring, or in another word, that would be a rigid body that looks like a spring, because this part can neither be stretched nor compressed. So it just looks like a spring, but it doesn't function like one. If you want to create a flexible or a dynamic spring in SolidWorks, you're going to have to do it through a different method, meaning creating small parts and assemble them together in a way that they would form a spring and mate them in assembly so they would move smoothly like in a spring and give you a functional spring. But that would require a lot of computing power. And in my case, that would slow down my assembly by a lot. So I'm gonna have to make my spring rigid and solve that moving issue in a different manner or with a different method. But if you have a computer which can manage heavy computing, then why not go ahead and create that dynamic spring, which I'm going to cover in a different video, and use it in your assembly. But for now, this would be my spring, and I'm gonna save it under spring, and yeah, that was it.
Hi, welcome back. In this video we're going to create the part shell. Let's just start by using the front plane and start drawing on it. Alright, I'm gonna draw a rectangle just as rough as this one. (17.5), and the length should be 59. Very good. Round this corner with the radius of 3 millimeters. Make a 3-point arc somewhere on the edge of the rectangle. Dimension it 2 millimeters. And also the radius of it should be 2 millimeters. The distance to the end or to the edge should be 15 millimeters. Very good. Now we don't need this line anymore, so I can just cut it using trim entities. That's very good. I go to the Features tab and revolve what I have created so far. Okay, very good. Using shell, setting it at 1, I'm going to open this side like this. Now click on the surface, make a sketch, draw a circle and set it at 8 millimeters and cut it through the part. That's your shell. Select the material 1060 alloy and save it under shell. Hi everyone, welcome back. In this video we're going to cover the hook for the spring. We're going to have 2 different hooks in total for our assembly, and this is going to be the first one. For that, I'm going to need a 3D sketch. Therefore, there is no need to choose a plane in the beginning. All I have to do is just to go to sketch, to this arrow, and click on 3D sketch. So then I'm going to take my line and draw something like this, up, and go to curve, tangential curve, then do something like that. This should be 2.5, and the radius here should be 1, radius here should be 2.5, and the distance from here to the center should be 5. And it really doesn't matter, but I'm just gonna make these 2 vertical along Y so it looks nicer and better. Now we go to sketch fillet, set it at 0.5 and round this corner. Now we're gonna look at this sketch from the top, so I'm gonna have to hold the shift key down on my keyboard and tap on the down arrow key on the keyboard as well, so it rotates my part 90 degrees. I go to 3-point arc, click on this point and click somewhere here, because all I need is a quarter of a circle. Set the radius at 1, and using the relations, make sure these 2 points are along X and these 2 along Y, or Z, sorry, yeah. So that would be the path for my slip bus. I click OK. That's my 3D sketch. You see, there is not a single 2D plane which can contain this sketch. Alright, I need a plane exactly at this point. Again, how I did the plane, as I explained it in the other videos, was to hold the control key down and click on an already existing plane. So I'm going to choose this new one and draw a circle on it, exactly where the path ends. Set the diameter 1 millimeters and reveal the sketch. Now we have to go to the features and use select boss or base and make the hook. Change the material to whatever and save your part as spring hook 1. Hi, welcome back. In this video we're gonna make the second spring hook. This is going to be again a 3D sketch, so we don't need to choose any 2D plane. Start off by clicking on this arrow below the sketch and activate the 3D sketch. Now choose line and draw something as approximate as this one, 2 millimeters up and a tangential with a radius of about 3, tangential radius 2.5, something like that, very approximate, and move straight to the right. Leave it there and use the 3-point arc, this point, and here. It doesn't have to be exact at this very moment. Okay, first thing first, we need some relations and dimensions. These 2 points should be along Y, and this point should be on this point. Sometimes SolidWorks doesn't cooperate much, but it's okay. We have to find our own way to make it work. Now I'm gonna do it old school and merge them. Yeah, better. This also should be 2.5, just like this one, 2.5. This is 3, and the distance between this point and this point mistake, sorry. From this point, or this line for that matter, to this point should be 2. So we leave it there. We're gonna round these 2 edges with 1 millimeter of radius. So this line is causing me problems because it's not on the same plane that I did the others, so I'm gonna have to do it again. Leave it there and do like this. Set the dimension 2.5, and the distance from here to here should be 2 millimeters. Very good. And set the center point on the other one. Okay, now they are on the same plane. Now I can round this corner also with 1 millimeter. This dimension here should be 2.77, and the general height should be 8.16. Yeah, good. Now hold the shift key down and tap on the right arrow on the keyboard to turn it 90 degrees. Draw a line and set it at 3 millimeters. Zoom in and round this point again by 1 millimeter of radius. Again, shift and down arrow key 90 degrees. Now we are working on the XZ plane. We can either use this or 3-point arc, doesn't matter. We're gonna have a quarter of a circle with a radius of 1. So the radius should be 1, and in order to have the quarter, these 2 points should be along X, and these 2 points should be along Z, right? Okay, so that would be our 3D sketch. Click Rebuild, choose the appropriate plane. If you don't have it, hold the Control key down, click on it, use these parameters, for example in this case parallel, and this point. Now I have a new plane exactly where my path ends, where it starts. There I'm going to draw my circle. 1, bigger than I thought. Alright, rebuild it, go to the Features tab and click on Solid Bus. Choose the profile and the path, then it gives you this hook. Change the material and save it on Spring Hook 2. Hi, welcome back. In this video we're going to cover the part Y joint. Alright, let's start by choosing the front plane and start drawing. I'm going to choose the line, start drawing something as approximate as this one. Now close the loop here, choose the arc and choose the 3-point arc here. Do an approximate arc somewhere in the middle. Go to Trim Entities and cut this line. Good. Now let's do some dimensions. Set this one at, well, you know what? Let's just leave it at 14 for now. This distance should be 5. Set it at 5. This should be 1.5. Its height should be 1. Same here, its height also should be 1 there. This distance should be 5, and this distance should be 13, and the whole distance should be 30. Very good. Now we can change this 14 to 2.5. That's very good. I need a point exactly in the center of my arc. Go to Dimensions and set the height at, let's just zoom in. I want to set the height. Appreciate your help. Yes. Set it at 1 millimeters. Exactly like this. Now I'm gonna go to Sketch Fillet, set it at 0.5 and round these 2 sharp corners. That's it. Now we can go to Features tab and using Revolve, create our own part. Good. Again, choose the front plane, go to Sketch, Sketch, and make it normal. Using a rectangle, do an approximate one here. The distance from the bottom here should be 2 millimeters. Height 2. Width 3. Distance to the end 1 millimeters. Sorry, 1 millimeters. Using the sketch fillet and 0.3 around these 2 corners. Very good. Go to the Features tab. Using extruded bus and the mid-plane option, extrude it for 1 millimeter. Very good. Now we have this. Now choose the top plane and start sketching. Go to Sketch and draw a circle somewhat so big. Set the diameter at 48. Very, very good. And the distance between the center to this end edge, 23 millimeters. Right? Very good. Hold the Ctrl key down, choose the center of the circle and your origin point and make them horizontal so it would be fully defined. Choose the line and draw 2 approximate lines from each corner or the upside and downside of your circle. Yeah, these two need to be equal, and each should be 25 millimeters long. Using trim entities, cut this extra line, go to the features tab, using extrude. You see automatically you have no other choice. For that matter, SolidWorks doesn't have any other choice but to activate the thin feature, and you cannot deactivate it. And the reason for that is because your sketch is an open sketch, it's not an open loop. As long as your sketch is not a loop, you have no option but to extrude it as or with the thin feature activated. Now put that on 1.5 and make this midplane and extrude it for 3 millimeters. I'm sorry, extrude it for 5 millimeters. Yeah, that should look like this. Activate the fillet, set it at 0.5, and choose all these 4 edges. 1, 2, 3, and 4. Now we have nice round edges all the way. Very good. Come back here, click on the surface, and choose sketch. Make it normal. Now draw an approximate circle exactly to this corner. Another one, and another one. Very good. Dimension the biggest 13 millimeter. The distance between the second and the first one 1.5, and the diameter for the smallest 5. Very good. Now I'm gonna hold the Ctrl key down, click on the center of the circles, and choose my origin once again and make them horizontal so they would be fully defined. Very good. Go to the features tab, choose extruded bus. Now 3 millimeters is correct. On my counter I want this and this, but in the other direction. Yep, that looks good. I'm gonna click OK. Now again, I'm gonna choose the very same sketch that I did for the next part or next step. Again, extruded bus. I want this area now, but I want it to start from the other side, so I'm gonna have to offset it 3 millimeters, reverse, and extrude it for 2 millimeters. So it started at 3 millimeters here and extruded 2 millimeters up to here. Right, very good. Now choose front plane, go to mirror, use this and this, put them on both sides, choose chamfer here, set it at 1, choose this edge and this edge, and click OK. That's your part. Right click on material, 1060 alloy, and save it under Y joint. Hi, welcome back. In this video we're going to create a hex nut with the outer side of 6 mm, inner diameter of 3, and the depth of 1 mm. So click on the front plane, go to the polygon, make it 6-sided, and draw one. Dimension it 6 millimeters. It is still underdefined, and it is because this side is not set as horizontal. Now it's fully defined. Create a circle inside and set it at 3.1 millimeters. Go to the features, extruded bus, and preferably use midplane. Set it at 1 millimeter and click OK. Change the material to whatever you want and save it under hex nut 6x3x1. Hello and welcome back. In this video we're going to create a shaft with a diameter of 2 mm and a length of 16 mm. So for that, draw a circle, set the diameter at 2 and extrude it for 16 mm. Change the material to whatever you want and save it under M2 or just 2x16. Hello and welcome back. In this video we're going to create an M3 shaft with a length of 20 mm. Select the front plane as always and draw a circle. Set the diameter 3 and extrude it for 20 mm. Change the material to whatever you want and save the file under M3x20. Hello and welcome back. In this video we're going to create an M3 shaft with a length of 35 mm. Choose the front plane as always, create a circle and set the diameter 3 and extrude it for 35 mm. Change the material to whatever you want and save the file under M3x35. Hi, welcome back. In this video we're going to create an M3 shaft with a length of 27 mm. For that we're going to choose the front plane and draw a circle. Set the diameter 3 and extrude it for 27 mm. Change the material to whatever you want and save the file under M3x27. Hello and welcome back. In this video we're going to create an M3 shaft with a length of 50 mm. So choose the front plane, draw a circle, set the diameter 3 mm and extrude it for 50. Change the material to whatever you want and save it under M3x50. Hi, welcome back. In this video we're going to create an M4 shaft with a length of 20 mm. For that we're going to choose the front plane, draw a circle and set the diameter 4 mm, extrude it for 20 mm and change the material to whatever you want and save it under M4x20. Hi, welcome back. In this video we're going to create an M4 shaft with a length of 20 mm. For that we're going to choose the front plane as always and create a circle, set the diameter 4 and extrude it for 30 mm. Change the material to whatever you want and save it under M4x30. Hi, welcome back. In this video we're going to create an M4 shaft with a length of 38 mm. For that we're going to choose the front plane and draw a circle, set the diameter at 4 and go to the features tab and extrude it for 38 mm. Change the material to whatever you want and save the file under M4x38.
Hi, welcome back. In this video we're going to create the ear cap. For that let's go ahead and choose the front plane. Now we're going to draw something like this using a line. Now I'm going to use spline here, something like that, and the sketch. let's just click on it once so we can see its vectors. Using these two vectors we can manipulate its shape. This vector over here, if we click on it, maybe zoom in, if you get to click on it here, yeah, we need to make this one horizontal. Alright, let's do some dimensioning. This should be 4 millimeters. This is 1.5. Oh, it changed everything, the shape. Let's just pull them back in manually. Reduce this so we can fix the geometry approximately. Yeah. Good, something like that. The height here is 1.3. Dimension here should be 5. Good. This should be 3.399, and this one here should be 1.672. Good. The angle between here and here should be 7.79. Yep, looks good. Now we have to go to the Features tab, use Revolved Bus, and revolve it along its axis here. I click OK. Change the material, and save your part under ear cap.